Greetings, and today we're going to do the independent t-test. And for that, we're going to be looking at two independent samples. And the word independent means two groups where this group here and this group here are separate. So one could be female and male. That's independent. If I wanted to show something that may not be independent, let me look at something like this. So here we have basketball players, here we have volleyball players, and there are people that play both. That is unacceptable here because we are trying to find out if there's a difference between the females and males. So independent, and it's called a t-test. And some call it independent two-sample t-test, but you can see it has to be two samples because we're going to divide our sample or our research into two. In this case, I'm going to use male and female. This is many other ones you can think of. You could divide by underweight, overweight. You could divide by married, single. But the t-test can only divide by two independent t-tests. So that's what we're looking at here. And in this case, I want to know, is there a difference in job satisfaction based on gender? Okay, and that means that I will have a job satisfaction score, and I'm going to find the mean score of the females and compare it to the mean score of the males. So my null hypotheses looks like this, that the mean of the females will equal the mean of the males. And the alternative is that the mean of the females does not equal the mean of the males. Here, just as an aside, if you think that the females are happier in their job and therefore would have a greater score than the men, that's very tricky, because if you believe that and it turns out that that's not true, then not only are you going to reject the null because they're not equal, but you can't accept the alternative either because they're not greater than. So basically the safest route to go is this, that they're not equal. And since we're going to use the 5 classical step hypothesis testing so that you can see how this goes, this is step 1. And when it comes to anything to do with a dissertation, you would be using the alpha of 0.05. This is the significance level. And it's used throughout. If you want to change this level, that requires really explaining why you would. So this is step 2, and we make all of these steps before we start. So when you're filling in IRB or you're putting in for a research grant, you must identify what you're going to do to begin with. You cannot change this after you've started. So number 3, and I know we don't need to do this with SPSS, but I'm going to show you the critical value, how to find it using a table and putting it on a normal curve. And you know that the normal curve looks something like this, and that by the time we get to 3 standard deviations away from the mean, we've looked after, well, 99.7% of the population. So anything that occurs past that is beyond. We know that it's not going to work well. So we need to find, in this case, I have 100 people, 100 in my study, and I need to know that. And I'm going to look up, well, it's called an inverse t-value. And the values we want is we're going to take the 0.05 and we're going to divide it into 2 because I'm sharing it, and then the number that I'm putting in here. So let me just show you what a table would look like. So here is a t-table, and you can see it talks about 1 table and 2 tail, or 1 tail and 2 tails. Ours clearly had 2 tails. we saw that by the fact that I have left and right. And so we're looking at a two-tail, and we're looking at 0.05, and we have 100. So if we go down the values to 100, we can see the value is 1.66. So let's go back, and we're going to now look at this value as being 1.66. I'm going to put this on and onto here. This section in the center looks after if my value for t turns out to fall between minus 1.66 and positive 1.66, I'm going to reject. Otherwise, if it falls in here, I'm going to hold on to it and say, well, you know, there's no difference between the men and women. So at this stage, I need to now find a value for t of our t-test. And so that we're finally going to look at the test statistic. So I could actually work this as a formula, or I can get SPSS to do it. It will give us a t-value. Once I have the t-value, I can put it onto my picture here, and you will understand why we've chosen a p-value each time. You see here we've drawn the picture. Okay, so I'm going to go into SPSS now. First, in my variable view, I'm going to look at job satisfaction, and it's a scale. I'm going to ask the SPSS to please tell me the mean score of job satisfaction for the males and the females. And I can do that in one run here. So analyze, compare means, independent sample t-test. It asks me what I want to compare. I'm comparing job satisfaction. How are you going to compare them? This must be nominal. And it asks me to define them. And in here, I'm going to put a 0 and a 1. The first one you have to know when you start. So for me, females are 0 and males are 1. So I need to put that in. Continue. There are no options in this one, so okay. And the syntax telling me what I've done. And let's have a look here, because I can see that the mean for the job satisfaction for females is 47. For males, I can see that it's 53. So is that significantly different or not? And I can come down here and look at the t-value that's given. So a little extra, and one that doesn't show up when we just are getting the idea of what the t does, is that one of the restrictions is that the variance of the two must be very close. And in this case, the variance is the square root of the standard deviation, or the square of it. So we can see this one is going to be 70 and this one's going to be 100. So it shows us here by Levine's that we do not have equal variances, because that test says that the null hypotheses, if we have equal variance, then it would be greater than 0.05. So we're using the bottom row. And our t-value is 0.901, negative 0.901. And our p-value is 0.370. So let's go back and put on negative 0.901 minus 0.9. Well, it's in here. So the test statistic came out to be minus 0.9. And we can see that that's clearly in the HO area. But in order for us to do this, each time we would require a table, either a t-table, which is because we're doing a t-test, a chi-squared table because we're doing chi-squared, an F-table because we're doing ANOVA. So because of that, SPSS has already converted the values to a probability. So what that's basically saying is that the p-value they gave us is 0.370. And if we already know that our alpha was 0.05. So what we're really saying is that if the probability of reproducing our experiment with randomly choosing another 100 men and women, the chances of reproducing our results, 37%. And we've actually said we're willing to accept the null if we can reproduce it for 5% of the time. So the chances of reproducing it this time is 37%. So our conclusion is that we will accept the null. And we can accept the null because our 0.370 was inside the area that we showed, or we can accept it because once the p-value is greater than alpha, we're going to accept. And again, let me repeat that. If the probability of reproducing our research was less than 5%, then what it's saying is that the null could not be true. If it were true, it would be easy to reproduce it. And here, we're saying that they're equal. So if we went out and found another 100 people, we would be able to get the same results 37% of the time. Anyway, I really hope that helped. And I hope to see you again soon.